Many competitive sporting events are held in hot, humid, or both environments. Because of this, strategies are sought to attenuate the deterioration typical of endurance performance in such conditions. One of the most commonly used strategies by athletes is heat acclimation, which we will simply call HA. Heat acclimation can invoke myriad positive adaptations which improve heat tolerance, including lower core and skin temperature, submaximal heart rate, carbohydrate metabolism, and sweat electrolyte content. Additionally, it can lead to an increased sweat rate, plasma volume expansion, and positive perpetual alterations with the resultant improved performance in the heat. Heat acclimation typically involves daily or alternate days of heat stress over a 5 to 16 day period, whereby core temperature, skin temperature, and sweat rate are elevated for 1 to 2 hours. To provide a constant heat stress across heat acclimation, isothermic protocols have been employed, whereby the external workload is manipulated within and between heat acclimation sessions to maintain a core temperature of approximately 38.5 degrees Celsius. However, many methods of providing constant heat stress across heat acclimation, such as the aforementioned and the efficacy of heat acclimation for invoking thermoregulatory adaptations, the commonly studied protocols may not be appropriate in certain circumstances. Some even bring financial burden. As such, a study stated that for athletes to optimally adapt to the heat, and in a time-efficient manner, protocols may best utilize a combination of active and passive heat acclimation. While heat acclimation has been studied in a range of able-bodied athletes, little attention has been paid to Paralympic athletes. These athletes are likely to be at heightened risk for performance decrements in the heat as a consequence of varied impairments in autonomic or behavioral thermoregulatory function. In some researches, there provided the first evidence of Paralympic athletes' capability to adapt to the heat, even to a relatively modest heat stimulus, where it is not known whether heat acclimation is also effective in endurance-trained Paralympic athletes. Further, it is now known how adaptations to heat acclimation in Paralympic athletes differ from able-bodied individuals. The aims of this study were to investigate the efficacy of a mixed active and passive heat acclimation protocol in the sport of paratriathlon. To negate the issue of potential cost and discomfort associated with isothermic protocols, a controlled relative intensity design was utilized by regulating exercise intensity using heart rate, which may be more applicable for elite athletes. A further aim was to determine how heat acclimation adaptations may differ between Paralympic and able-bodied athletes. 29 para-triathletes and triathletes were recruited to partake in the present study. From this pool, 3 separate groups were formed: a group of elite para-triathletes, an able-bodied heat acclimation group, and an able-bodied control group. Participants trained at least 5 times per week, and all were provided written, informed consent and approved procedures. No participants reported being heat acclimated prior to the start of the study. Both Paralympic and able-bodied heat acclimation groups undertook an 8-day heat acclimation period. Due to the nature of para-triathletes' pre-competition routine, it was not possible to gain a direct performance measure in this group. However, this was undertaken in the able-bodied heat acclimation group pre- and post-heat acclimation. The able-bodied control group solely undertook the performance trials with no heat acclimation to determine the natural variation in performance. During the study period, all participants were instructed to maintain their usual training routine. All testing was performed in the same geographical location with an average outdoor environmental temperature during the study period. Participants were free to drink, during all visits, but fluid intake was restricted to water. Participants were instructed to abstain from alcohol for 48 hours before every trial while standardizing food, fluid, sodium, and caffeine intake. During every trial in the heat, participants were instructed to keep clothing consistent. All trials were scheduled at the same time of the day to limit the confounding effect of circadian rhythm variation. A series of tests, namely graded exercise tests, familiarization in performance trials, heat stress tests, active heat acclimation, passive heat acclimation, and some analytical methods were done during the whole study period. In addition to these tests, statistical analysis were also conducted using IBM SPSS Statistics 23.0 software with statistical significance set at p less than 0.05. Results for majority of the tests showed little to no significant differences. A mixed active and passive heat acclimation protocol controlling exercise intensity by heart rate induced positive thermoregulatory adaptations in para-triathletes and able-bodied triathletes. Both groups displayed reductions in core temperature, blood lactate concentration, rating of perceived exertion, and thermal sensation during a submaximal heat stress test with significant plasma volume expansion. Furthermore, the able-bodied heat acclimation group presented additional adaptation, including reduced heart rate and skin temperature with an elevated sweat rate. This is the first evidence of differences in thermoregulatory variable changes to the same protocol between Paralympic and able-bodied athletes matched for physiological variables. The submaximal heart rate controlled exercise heat acclimation resulted in a constant relative intensity between heat acclimation sessions with an able-bodied heat acclimation group capable of producing a greater cycling power output for a set intensity over the study period. Finally, there was evidence of a direct performance benefit as the able-bodied group improved their cycling power output during a 20-kilometer performance trial in the heat to a greater extent than the natural variation shown in a non-acclimated matched cohort.